Alright guys, we're going to blaze forth into the next chapter of our textbook, How to Think Like a Computer Scientist. Variables, expressions, and statements. Values and data types. A value is one of the fundamental things, like letters and numbers, that a program manipulates. For example, 2, or 2 plus 2, which is 4, or the string hello world. All of those are values. Now, a programming language needs a way to codify what kind of data that is. So there are data types. There are ints, integers, like 4. And then there are strings. A string is a series of characters in quotes. There's also a float, which is a floating point number. If you don't know what kind of data type you're looking at, you can make Python tell you. So if I do a is equal to 10, well, if I didn't know that that was an integer, I could get it to tell me. I could do this. Type a. What this is saying is call the type function and pass in the a variable, and that will tell me that it's an int. Let's make b contain a floating point number. So type of b is a float. C we're going to make equal to a name. Ned Flanders. Type C. There we go. So a name is a string. One more data type that we'll be hitting occasionally is a bool, which is a Boolean variable, like true or false. So let's set that D equal to true. And there we go. That's a bool. You don't have to store it into a variable first. You can pass the data directly into the type function. So what is 4.44? What is that going to print? That's going to be a float. What about 0? Well, it doesn't have a decimal point in it, so it's not a float. It is a int. Yeah. So even if two things look the same to you, they're not the same thing to the language. And oftentimes you can get away with using them interchangeably in Python. Other programming languages are pickier. Python is not what is known as a strictly typed language. A strictly typed language, you have to define every variable in advance before you put data in it, and then you cannot put the wrong kind of data in it. So if a is an int here, then if I did this in a strictly typed language, that would give me an error, because that's not an int, it's a float. So C and C++ and Java are strictly typed languages. That would cause an error. However, Python is not a strictly typed language. You can store pretty much any kind of data into the variable. Even though a is an int here, it's okay to turn around and to store a name in it, a string. No problem. And then I can turn around and store a floating point in it. Or I can store a Boolean value in it. Can't do that in a strictly typed language. These would be generating errors left and right in Java or C++ or the like. But it's okay in Python. You can reuse variable names. Now, is that a good idea? No, not really. If you start storing integers into a variable called a, don't change midway through the program and decide, oh, by the way, now a is going to do something different. And better yet, don't use single letter variable names. Those don't contain any meaning to the reader of the program. Your code should be readable to another human. If you hand somebody typewritten code, it ought to contain enough information that they could figure out what it's doing, even if they're not a master programmer. So, rather than T, use temp, or better yet, use temperature. Rather than S, use salary, and so on. That makes the program more descriptive. Rather than TR, use tax rate. Now, sometimes it's okay. We talk about X, Y, and Z coordinates. You may as well use X rather than typing X coordinate. That's a bit much. All right, for preferred names, let me see if I see things like Mr. Superior and no, y'all were actually pretty serious. Thank you very much. Unlike some languages, you can either use single or double quotes to enclose a string in Python. If you're a Java or C programmer, this would not work. You could not do A is equal to and then use a single quote but type in a string. That would be an error. But in this language it's okay because you can use either double quotes or single quotes, and Python treats them the same way. However, once you use one, you can't then turn around and use the other one. If I started off with a single quote, I can't end it with a double quote. There's even something called a triple quote, which I've never seen in any other language. And a triple quote can span multiple lines. So let's say my book is equal to one fine day, except I'm going to use a triple quote. In the middle of night, two dead boys got up to fight. And now I'm going to close it with three more quotes, and there, that's what my string is equal to. So if I print my book, it prints all that stuff out. Now, do you really take advantage of that very often? I don't know. I never do. But if you wanted to, you could. I don't know who invented it, but it's an actual little silly rhyme. One fine day in the middle of night. Here it is. It may even be a song. Oh my. Two dead boys got up to fight. Back to back they faced each other, drew their swords, and shot one another. One was blind and one couldn't see, so they called in a dummy for referee. A blind man came to see fair play. A mute man, this is way longer than the version I ever heard. Here we go. It ends in this one. A deaf policeman heard the noise and came and shot the two dead boys. If you don't believe this story's true, ask the blind man. He saw it too. Alrighty. That ought to be required learning, in all grade schools. So what is a variable? A variable is a named place in memory that can contain a value. Here we're assigning the value, the string, what's up doc, into a variable called message. Here we're assigning the value 17 into a variable called in. And here we're assigning an approximation of pi into a variable called, conveniently enough, pi. Here we go, the equal sign. Other texts call it the assignment operator. This text calls it the assignment token. You just have to make sure that you don't mix it up with double equals. Now when I'm reading code off as I type it in, I may not always say assignment token. Actually, it's probably going to happen never. I will just say A equals 3. But if you're going to compare two values, like with an if statement, if I say this, if A equals 3, you just have to remember that when you're assigning a value, when you're copying a value, use one equal, but when you're comparing values with an if or a while, then use two equals. And if you mess that up, then it won't work. So that printed 3 because A is in fact equal to 3. But if I messed up the syntax, if I said A is equal to 3 without making it two equals, invalid syntax. So 1 equal is assignment, 2 is to compare. So variable names and keywords. You can make variable names as long as you want, really. But past a certain point, it's kind of a diminishing return. Do you really need to do my name or price of tea in China? No, that's silly. You can use underscores in your names if you want to. And some programmers like to use underscores. Some programmers like to mix uppercase and lowercase in order to make it easier to read. So you'll see some people do this. Tax underscore rate is equal to 0.75. Or you'll see other programmers do this. Tax rate is equal to 0.75. And I actually don't remember which one this text prefers. When you're learning Java, everybody will say to do it like this, without the underscores. If you like underscores, it's totally cool. There are a couple of rules, though. One of the rules is that your variable name, while it can contain numbers, cannot begin with a number. So you can't do 2008 tax rate is equal to 0.8. That's an error because you started a variable off, the variable name, the identifier, with a number. Instead, you'd have to do something like tax rate 2008. Woo. I forgot to give it a value, so that's why that's an error. Tax rate 2008 is equal to whatever. That works. There are a couple of variable names that you can't use. You can't use words that are already defined by the Python language to do something else, like the word if. You know, if is a very specific Python word. It even shows up in a different color when you type it. That's a good hint, is if you're using idle and it gives it a different color, it's not a good variable name. So if I do this, if is equal to 7, nope, that's invalid syntax. What are other keywords? While is another word. The word class. Print is something slightly different, but you're on the right track. These are the Python keywords. There may be some more, but these are the keywords. These are the words that define the syntax of the language. And notice print is not in there. Neither is the word input. And I think we've used both of those. I'm not sure we've used input yet. Those are what are known as built-in functions. They come with the language. And you shouldn't use those as your variable names either. But you really can. I could do this. Print is equal to 3. But unfortunately, what I just did is erase the built-in function for print, and now I can no longer print anything. So, you don't want to use words that light up in colors as your variable names. And the only place that annoys me is sum. I love the word sum. It's a great variable name. You know, the sum of two numbers, you know, or I'm calculating a sum. Can't because it is actually a function. What does sum do? If you give it a series of values, well, that's not right. If you give it a series of values, a list of values, it will add the sum up of them. So the sum of 0, 1, 2, and 3 is 6. There we go.
If you don't put the brackets, it's just going to ask for 2 arguments.
It won't work at all. But well, let's give it a try. The sum function requires it to be a list, and to make it a list, you have to put it in square braces. So a variable can not only contain one piece of information, it could be an entire list of values. So I could say, you know, I don't know, profits equal to, and then I could type in a series of numbers. 100, 200, 55, 0. Things are starting to look really grim. We earned a -10, but the next day we made it up and earned 19.99. There we go. So, if we print our profits, this is not going to work because I blew away my word print. I'm going to start a new window. Restart shell. The reason I'm doing that is so that I can get my print function back. There we go. And then if I do print profits, it's just going to print that list out. But I could do sum of profits, and it will add all those numbers up. We'll do a lot more with lists later, but I want you to have the idea that not only single values can be stored. In some languages, these are known as arrays. That is an array of numbers. And this language is called a list. So anyways, these are our keywords, but you pretty much know to avoid them just because they change color when you're typing them in. A lot of these you don't really use very often. We will use if and elif which means else if. We will use return and or, which is used in conjunction with and. We may use break. We might use continue. I'm probably going to skip doing that one. Some of these I have no idea what they do. Yield? I don't know. Non-local? I've never used that one. Anyways. Keywords define the syntax of the language, and then built-in functions like print and sum enhance the language. So a statement is an instruction that the Python interpreter can execute, like a print statement, or a equals 3 plus 1 is a statement. So when you type a statement into the shell, Python goes ahead and executes it. I don't know why it says statements don't produce any result. I guess they're trying to differentiate it from an expression. An expression is one or more variables and literals mixed up with logical or mathematical operators. 1 plus 1 is an expression. Even the number 1 all by itself is an expression. A string is also an expression. So I'm going to go back here and I'm just going to do a couple of expressions. 3, that's an expression. 3 plus 3, that's an expression that results in 6. 3 times 3, that's an expression that results in 9. Hello, that's an expression that results in the word hello. Hello plus there is an expression that equals hello there. Notice that strings and numbers are not the same thing. If I do 3 plus 3, that equals 6, but if I do 3 in quotes plus 3, 33. That's known as concatenation. That's a real fancy word meaning adding two strings together, adding one onto the other, appending one onto the other. So this one got appended to that one to make a new string. So when you have a string, you can't do math on it. Say if I do this. My favorite number, fav, is equal to 3. And then I try to print out fav times 2. Oh, yeah, you would do that, wouldn't you? Hey, that's cool. Anyways, it's not a number. If I try to calculate what percentage fav is out of 200, I can't do this. Print fav divided by 2 plus 4. You know, I can't use it as part of an expression like that. And the reason why is that even though it looks like a number, it's a string, and a string is stored inside the computer completely different than a number. To get it converted into a numeric format, we can use one of the two built-in functions, either int or float. We could do this. Either fav is equal to int fav. That turns fav into an int. And notice now when I print it out, it doesn't have quotes around it. It is no longer a string. If I do type fav, it tells me that it's an int. Now I can do math with it. Now I could do print fav divided by 2 plus 4. So anytime you ask the user for input, if they're inputting a number, you're going to have to convert it, because the input function returns a string. If I do this, a is equal to input, what is your age? Well, what is my age? Let's say I'm really old. I'm 98. There we go. Now I'm going to print age. No, I'm going to print a. Excuse me. 98. Looks great. Looks like a number, huh? But it's not. Print a plus 10. 98 is not really a number. It's a string. I would have to convert it into an integer or a float before I could do math on it. If I just print it out all by its lonesome, you know, in the shell, it puts quotes around it indicating that it's a string. Or if I'm curious about the type of it, I can do type of a, and it'll tell me that it's a string. I can make it a float though, or an integer. So a is equal to float a. That takes the a value, 98, and turns it into a floating point number. So now if I print a out, we see it tacked on that 0.0. and there's no quotes around it. Another built-in function is len, which stands for length. That's the length of the string. That's not what I wanted to grab. I want to grab that. So if I do name is equal to input, please enter your name. Then I type in something, Joe Johnson. And then I do len of name. It'll tell me how many characters long that is. So far we've seen only a few built-in functions, but let's go ahead and make a list of them. Print, that's the one we use the most often. Input, sum, int, float, and len. And I could give examples of each one of these, but yeah, print, hello. Nah, I'm not going to give examples of each one here. I'll come back down here and then add examples. So print hello, that's one of them. A, or name, is equal to input. What is your name? That's an example of the input function. Sum. A is equal to the sum of the numbers, and I have to put these inside braces, 1, 2, and 3. X is equal to the integer value of the string that contains the word 300. There you go. Y is equal to the floating point value of the string that contains 3.33. And length, we're going to get the length of the name. There we go. These are examples of those 6 built-in functions we've seen so far. Although when we were using int and float, we passed in a variable. I did x is equal to int x, or y is equal to float y. Operators and operands. Operators are the mathematical or logical symbols, like plus, minus, multiply, divide. There's one we may not immediately be familiar with. Star, star. That means to the power of. And a lot of languages, for some reason, do not have a power of operator. Java and C++, for example. So it's nice that JavaScript does. So if I want to find out what 10 to the power of 2 is, 10 star star 2 is 100. So our operators, we know addition, subtraction, multiplication, division, and that, which means to the power of. And then there's one more. Percent. The technical name for this is modulus. It means remainder of. If you do 10 divided by 5, what does that equals? 10 divided by 5 is 2. But if you did 10 modulus 5, well, does 5 divide into 10 evenly, or is there a remainder? It's even, so it goes in evenly, so it has no remainder. But what about 11? If you divide 11 by 5, it goes in 2 times, right? But after you do that, what's left over? 1. So you get a remainder of 1. And so on. 5 goes into 12 2 times, with a remainder of 2. So what is 5 modulus 2? It is 1, correct, because 2 goes into 5 2 times with a remainder of 1. So the way to think about that is 2 goes into 5 2 times with a remainder of 1. Modulusing something by 2 is a good way to determine if it's even or not. If x modulus 2 equals 0, then you know that when you divided it by 2, it didn't have a remainder. If x modulus 2 is equal to 1, then you know it's an odd number. I'm going to pop open a programming file, do save as. So I did file new inside of idle. I'm going to call it even odd. Alright, so I'm going to ask the user for a number. To ask them for a number, I need to either use a print in an input statement, or I could combine them, because in this language, unlike a great many others, there's a version of the input statement that prints something out. So I'm going to do x is equal, and I'm going to do n. That's our number. N is equal to input. Please enter a whole number. Whole number is a fancy or silly way of saying int. But at this point, it's a string. I have to convert it to an int. So I'm going to do n is equal to int n. Now it's a number, and I can do math on it, like modulus. If n%2 is equal to 0, colon, print n comma is even. Now I'm going to stop indenting. If n%2 is equal to 1, I'm going to print n is odd. And heck, let's see if it's evenly divisible by 10, if it's a multiple of 10, 10, 20, 30, or 40, or 50. If n%10 is equal to 0, we will say print n quote is a multiple of 10. I'm going to run it. It says please enter a whole number. I'm going to type in, I don't know, 11. It says 11 is odd. What is 11 modulus 2? Yeah, 1. Everybody understand why? Because if you divide 11 by 2, you get a remainder of 1. I'm going to run it again. Please enter a whole number. 200. 200 is even, and 200 is a multiple of 10. Can you modulus by a floating point number? Can I do 5 modulus 2.5? Wow, you can. Most languages do not support that. But 2.5 goes evenly into 5. 5 modulus 3.14159. I'm being goofy here. Yeah. Huh. Most languages require modulus to use integers. This one does not. We're going to change this program a little bit. But we're going to start a new one. X is equal to input. Please enter X. then we have to convert that. X is equal to int x. Y is equal to input. Please enter y. Y is equal to int y. And now we can do a little bit of math, like we could add those two numbers together, or we could multiply them, or we could modulus them. So I'm going to do this. Print x, comma, modulus, comma, y, comma, equals x% y. I'm trying to add spaces to make it very clear where you put the commas and stuff, but you don't need to space it out like that. Oh, bless you. So I type in 10 for x, I type in 3 for y, and 10 modulus 3 equals 1. Everybody get this program such that it is to work. I don't want to blaze boldly when people are getting syntax errors. Our homework assignment is going to be to modify this program or to write another one that does something like this.
So under the input where y equals integer y,
Right.
that's pretty much just letting you know it's a number or an integer.
Right, it's taking whatever was typed into y, whatever was stored here, and changing its format so it's now a number.
Okay, what if you put that before the input? Please,
You don't have any data in y, so that would be an error. Yeah, if you reverse the order of this, in a way it looks kind of good. Oh, by the way, I want you to start storing integers in y, but you don't have any data in y, so it has no idea what y is, so it could not do that conversion. Other languages do it a little bit differently. Don't type this, but in other languages you would do int x comma y. You would say x and y are integers, and then you wouldn't have to do any conversion after that in order to get that to work. All right, we all done typing? The only reason I'm waiting is because our homework assignment is going to be based on the last part that we did here. I'm going to go ahead and add some comments just to make this look better. My name here, my date here. Demonstrate math. That's what this program does. And I'm going to call this part 1. the thing that does please enter a whole number, and I'm going to call this one part 2. Without describing what part 1 and part 2 do. But the reason I'm doing that is so that later on when I give you a homework assignment, I can say, make your code look like part 2. And it'll make sense. So type converter functions, int, we've used them. However, type conversion can't do a miracle. If it doesn't know what kind of data that is, it'll get an error when it tries to do it. Like if I do this, a is equal to 3, and then I try to convert a into an integer. Does the computer know that those letters mean the number 3? No, it does not, so that gives us an error. Whatever is in the string had better be a valid integer, or else I'm not going to be able to turn it into one. So that works fine. Something that you might expect to work, like this, 3.0, that looks like an integer, but it's not. It's really a floating point number. The compiler doesn't take the time to look at this and go, oh, by the way, that's really a whole number, so it's safe to convert it to an int. Instead, it just gives you an error. That wasn't an int, it was a floating point number. So order of operations. Order of operations means if you have a long string of operations, pluses and minuses and multiplications and divisions, which part happen first? I'll show you what I mean. A is equal to 3 plus 2 times 4 minus 1. What does that equal? Yeah. So some of y'all, or maybe you all, already have the idea that multiplications happen before addition and subtraction. So the order in which this gets done is this part gets done first. So we get a is equal to 3 plus 8 minus 1. And then it goes ahead, and now that all the multiplications have been done, it does the additions and the subtractions. So there is a little acronym, a mnemonic, PEMDAS, which you probably run across. This is the order of operations. Parentheses are done before anything else. And then exponents are done before anything else. After that, multiply and divide are done. And then after that, addition and subtraction are done. Now, multiplication and division have the same priority. So they just happen left to right. Addition and subtraction have the same priority, so they're just done left to right. But otherwise, you have to follow these rules. So if we do a is equal to 3 plus 2 times 4 to the power of 2 plus 10. What gets done first, according to PEMDAS? Well, we have to do the parentheses. So everything in the parentheses has to be done before we come over here and do that. But you're right. Then exponents. Exponents get done before anything else does. So we will do the exponent first. 4 is 60. Now we can do multiplication and division. So we just do those left to right. 2 times 16 is 32. Now we've done everything. Well, we haven't done everything in the parentheses yet, but I'm going to cheat and go ahead and do that one. Alrighty. And then lastly, now we can do addition and subtraction. And they're equal, so we would just do them left to right as well. So that's 35 plus 20, which is 55. On some versions of Python, not idle, but one called PyScripter, if you use an input statement, it pops up a cute little window like this. Ours doesn't do that. Composition. Composition means that you can create larger expressions by combining them. 3 plus 2 times 5 is composition. Composition is the art of looking at something like this and figuring out how you're going to express that in the formula. And you just have to kind of be careful because math books will show you something like this. 2 pi r. And we're supposed to know that that means 2 times pi times r. So circumference is equal to 2 pi r. You'll see that in a book. But if we're going to make this a program, we would do circumference is equal to 2 times pi times r. Or you may see that you may see parentheses, a times 3 plus b. That's not valid Python. You can't just put two things next to each other and hope that they get multiplied together. So the book will say that. That's the formula, but we have to say a times 3 plus b. Or, a b plus 2ac. There we go. How do we turn that into valid Python? A, what's next? Times b plus, what's next?
2 times a times c.
Yep, 2 times a times c. There we go.
Quick question.
Yes, sir.
On the circumference part up there, if you wanted to get the program to ask what your radius is, that would go after you state the circumference because it doesn't know what it is yet? Or
Right.
Or the
We're
radius.
going to have to let them type in the radius.
And
Otherwise, this is going to be an error. And also, we have to have found a way to specify pi. So quite often, you'll just see people do this, 3.14159, right in their program. Yeah, this expression here, a times 3 plus b, that would totally fail unless we had already assigned a and b some values or let the user type them in. So here we go. Here's a formula for a circle for calculating the area of it. It's equal to pi r squared. Let's add on a part 3 to our little program that we've been typing in, the even or odd program, that calculates So I'm just going to put a comment that the area is equal to 2 times pi times radius.
pi r squared.
Yeah, why did I do circumference? Thanks. It's equal to pi times radius to the power of 2. Or pi times radius. Either one works. But we don't know what the radius is. So we have to ask the user for the radius. Radius is equal to input. What is the radius of the circle? Now it's a string and we have to convert it, but we don't want to convert it to an int because they may want to say that it's 10.5 rather than just 10. So let's convert it into a float. Radius is equal to float radius. Now we can calculate the area. Area is equal to pi, but we're just going to say 3.14159 times radius to the power of 2. Now let's print our results. Print the area of the circle is run it and see if it works. Radius of the circle. We have a circle with a radius of 0. So the area is 0. That's kind of stupid. If I ran it again and I entered a radius of 1, then the area would be 3.14159. If I ran it with a radius of 10, then the area of it would be 314. There we go. So the radius of the circle is 10, so the area is 314.159. Now I am absolutely sure that Python has a way of getting the value of pi that is more precise than 3.14159, because you know pi is endless. It's an irrational number. It has no end. Now we could, if we wanted to, and don't do this because this is not necessarily good programming, you can start to combine these things. We have 4 steps here, but what if we wanted to combine these 2 steps? I'm going to just make a comment that this is a revision of it. Revision A, and don't do this, but if radius is equal to the input of this, then I could replace that word with that. That code is valid. Now, if radius is equal to all this, then I could take this and I could substitute it for that variable. You kind of see where I'm going with this. And then lastly, the ultimate in annoying revisions. If area is equal to all this, then I could do that. Don't do that. That looks horrible. Which of these is the easiest to understand? You will see people do this, but that's about as far as you want to take it. This just saves you the step of having to create a separate line to do that conversion. I think this is best. I think that the 4-line one is the best. But you can do that. What we're doing is we're using functions and getting the return value of those functions and passing them in as input to other functions. And so here we have nested functions and stuff like that. And sure, that's great, but if there's a typo in it, you have to stare at it for a long time to figure out what was wrong with it. You know, say that I forgot a quote, you know, like that. Or not a quote, but a parentheses. Then when I type that in and try to run it, it's not going to work. And I'm going to go, what? I don't know why it's not working. So, you know, the more complex the statement is, the harder it is to debug and fix problems in it. So there's no reason to do that, but you can.
When you're in the Python shell,
Mm-hmm.
if you want to rerun your program, is there a certain way, or do you have to exit out and run module again? Like,
If you have typed stuff into Python, like say I'm going to write a little program. Let me close the shell and start it again. I'm going to come up here and say I've entered a little program up here. I've said A is equal to input. I don't know why I'm using an uppercase A. Enter A. And then I type in 10. If I want to do that again, if I wanted to run that again, I would actually have to type it over again. A is equal to input, enter A. If you're running a program like this, and you've run it, and you wished, yeah, I messed it up. And yet, you have to run it again. You just have to flat out run it again. But you can make a program loop.
if that's what I meant.
But you have to code that into the program. Let's go ahead and give an example of that, even though I don't expect you to be doing this unless you just really want to. This is an example of a loop. In fact, I'm going to make it a new program. I'm going to do File, New File, do Save As, and call it Loop or Loopy. And so I'm going to start it off with this line that says repeat is equal to quote y. And I'm doing that so I can add a while statement. While repeat is equal to y, colon, x equals input, enter x. Print x squared is, comma, x to the power of 2, x star star 2. But now we're going to ask them, do you want to repeat? Repeat is equal to input continue y/n. And then let's add a final statement that is unindented because it's outside of the while loop that says done. That just tells us that the program is over. And it's a good idea to make your programs loop until the user wants to quit, because you don't want to make them have to go up and hit run each time. So enter x, 100. Ew, and it blew up. What did I do wrong in this program? I didn't convert it into a digit. You're correct. I'm going to make it a floating point number. So above that print x squared is x to the power of 2, I'm going to do x is equal to float x. So that's the line that I just had to add. Right there. So enter x, 100, x squared is 10,000. Continue? Sure, why not? Enter x, 9. X squared is 81. Continue? No. And it stops. So the while statement, this creates a loop, and it's going to repeat until this condition is no longer true. So as long as they type in an uppercase y, then this condition is true. And when it gets to the bottom, it'll come back up here and do it again. But if they ever type in anything other than an uppercase y, this condition is no longer true, and it stops. That is an example of a while loop. And there are other ways to structure this, but we'll go with that. All right, anybody have typos that they need help fixing? Two commonest mistakes. One is getting your indentions wrong. The other is forgetting your colon. Okay, 3 commonest mistakes. And the third is not closing your quotes properly. Alrighty, so our homework assignment. We have this program here. This part 2 here. Using the above code as an example, write a program that will ask for 2 numbers x and y. I think we can zoom in on that so that and then print the following calculations. X multiplied by y, x divided by y, x plus y, x minus y, x modulus y, and x to the power of y. So our program already does this one. But you're going to add more calculations. You're going to add 1, 2, 3, 4, 5 more print statements in order to accomplish that. That's the first part of the assignment.
Is the reason you put print done at the end of it so it doesn't close the program, or because I just try to run mine and I put everything in it and then close it like as soon as it gave me the results for the last thing I asked.
I just put print so that I have something at the end of the program.
There, that was good.
And you're right, it closes it. That's a good point. If you're launching the program by double clicking on it, let's say I go out to my code directory and I find my even odd program. I double click it. Well, I certainly was hoping to see it do something. Okay, I'm going to run loopy instead. There we go. Enter x 7. 7 squared is 49. And then I hit no because I don't want to continue anymore. Poof, it closes. You don't get to see what it does. So the best thing to do is to not double click on the application, but to edit it with idle, you can right click and choose edit with idle, or to choose open with and open it with idle. Right now, idle isn't even listed. But anyway, so if you right click and choose edit with idle, then you get it in a window form and you can run it and it doesn't close the output as soon as it's done. If you can't find it that way, you open idle first and then you just do file open. So I launch idle, I do file open, and then I go and find the file. So if you double click it, it's running it in the Python shell, and as soon as that program is done, poof. If you don't want it to poof as soon as it's done, you can fix that by adding one last input statement. Let me find that loopy one again. Okay, so here, instead of saying print done, I could do this. Input, press, enter, or done, press enter. That way, when I run it, I don't want to continue, it says done, press enter. So do you see what I did there? That way, it gives you a chance to look at your output before it closes the window.
Yeah.
So you can do that if you want to. And since I don't care about the input in this case, I'm not even bothering to store it. Okay, so that is one, and I had an idea for a second part of the program, and it's not coming to me now. Oh, yeah. We had another portion of this first program, the even or odd one, that calculated the area of the circle. So part 2 of the assignment. using the above code as an example, write a program that will calculate the volume of a sphere. The formula for a sphere is volume is equal to 4 divided by 3 pi r cubed. I'll go ahead and put the times in. And you know how to do exponents. That's just going to be 2 stars. Okay. So that's part 2 and this is part 1. Shouldn't take too long. So let's make a Dropbox for today's stuff. We'll call this math homework. That program, even odd, and if you want to upload the loopy program as well, let's upload both of those.
If we did it all under the same program.
Then that's fine.
Okay.
Yeah. It was actually supposed to be an in class. Okay, if you refresh your Dropbox, you'll see in class 3. Go ahead and put the script or scripts that you wrote today in there. And then homework 1 is the math homework. Which is the one that I just typed up. And that is something different than I usually do. Usually I name the in-class assignments with letters and the homework with 1. In which case this would be in class A, in class B, in class C, in class D, and then homework would be 0, 1, 2, and 3. I don't know why I didn't do that this time. Alright gang, we're done. I will see y'all on Monday.